Welcome to All Force e-learning. We are going to discuss differences in between unimolecular reactions and bimolecular reactions in session 7 here. In session 6 we have discussed about nucleophilic substitution reactions types and the mechanisms of unimolecular reaction and bimolecular reactions. Now we will discuss about differences in between SN1 reactions and SN2 reaction here. Here SN1 reaction is given, SN2 reaction is given. SN1 reaction, what type of alkyl halides undergoes unimolecular reactions? Majority of the tertiary alkyl halides undergoes unimolecular reaction. Tertiary alkyl halides. Tertiary alkyl halides means nothing but the reaction proceed via more stable carbocation intermediate. Carbocation intermediate. How can you explain the stability of carbocations? Means based on the inductive effect, wherever resonance is given, based on the mesomeric effect, we can explain here. So the reaction proceed by a more stable intermediate. So what is the reactivity order of alkyl halides in unimolecular reactions? Tertiary alkyl halide reactivity is greater than secondary alkyl halide, reactivity is greater than primary alkyl halide, reactivity is greater than normal alkyl halides. Normal alkyl halides here. So we will discuss about what type of compound has greater reactivity in nucleophilic substitution reaction after this completed differences in between SN1 and SN2 reactions. Because next topic is factors affecting on nucleophilic substitution reactions. In that one we will discuss about reactivity of that given compounds. But according to difference order, tertiary is more, after then secondary, primary, normal compound. If you go to SN2 reactions, what type of compounds undergoes bimolecular reactions? You remember, primary alkyl halides undergoes bimolecular reactions. Nothing but normal primary alkyl halides are very favorable for bimolecular nucleophilic substitution reactions. Normal alkyl halides are highly favorable for bimolecular nucleophilic substitution reactions. While writing the mechanism of bimolecular reactions, we can explain that concept. Wherever bulky group is given like tertiary group, bulky group is given like tertiary group, attacking of nucleophile somewhat difficult. Due to that reason, steric hindrance less compounds easily undergoes nucleophilic substitution reactions. What type of nucleophilic? Bimolecular nucleophilic substitution reactions. So based on the steric factor also, we can explain bimolecular nucleophilic substitution reactions. So what type of compound? Primary alkyl halides undergoes SN2 reactions. If you check the reactivity order, normal primary, here somewhat bulky nature increases, here increases, here completely increases. So steric hindrance, steric effect is more, means reactivity is somewhat less here. Primary compounds are more active compounds in bimolecular nucleophilic substitution reactions. Now already I told you, primary alkyl halides means unimolecular reaction proceed via carbocation intermediate. In that reaction, carbocation intermediate is possible, means the carbocation is having sp2 hybridization, rearrangement is possible. Already have given mechanism for unimolecular nucleophilic substitution reactions. So what type of intermediate is possible in unimolecular reactions? Carbocation, positive carbocation intermediate is possible in this case here. Supposed to be If more stable carbocation is possible means that compound reactivity is more in unimolecular nucleophilic substitution reactions. So different type of tertiary compounds is given. First we have to find out the stability based on the inductive effect and mesomeric effect. By using that reaction, by using that concept, we can find out given compound is having more reactivity or less reactivity. So you forget about that one. Now carbocation intermediate is possible in unimolecular reactions. Wherever bimolecular reaction is given, bimolecular reactions proceed by a transition state, less stable intermediate, transition state form the products here. So here carbocation here, transition state here, exactly attack that nucleophile exactly opposite of leaving group. So due to that reason form the transition state. Nothing but transition state intermediate is possible in this case, carbocation possible in this case. Now non-concerted reactions, here multiple steps are possible here. The type of reaction is generally called what? Non-concerted reactions. Here single step reactions, concerted reactions. Unimolecular reactions are non-concerted reactions. Bimolecular reactions are concerted reactions. Already I told you carbocation is possible means rearrangement is possible. The first priority is given to rearrangement product. If rearrangement is possible means we have to write the product based on that rearrangement concept. So in unimolecular nucleophilic substitution reactions, rearrangement is possible. Means less stable carbocation convert into more stable. Primary carbocation convert into secondary convert into tertiary. The type of rearrangement is generally called Wagner-Mervian rearrangement. So here rearrangement is possible in SN1 reactions. Here no rearrangement because formed intermediate is somewhat less stable intermediate transition state. So no rearrangement. We have to write the product as it is without rearrangement here. In unimolecular nucleophilic substitution reactions, rate is directly proportional to first step. Means how you know that one? First step is according to mechanism. First step is slow step. That's why we have to take first step only in this case. So rate is directly proportional to first step. In unimolecular reaction, first step is bond cleavage step here. Rate is directly proportional to first step. Here also same thing. Why? Because in bimolecular nucleophilic substitution reactions also first step is slow step. That's why rate mainly depends on first step only. Again, the first step is bond formation step, bond making step, bond breaking step, bond making step. Rate is directly proportional to first step in this case. Rate is directly proportional to Rx. Means what here? According to nucleophilic substitution reactions, first step is bond cleavage step. Only one substrate involved in that step. Only one substrate. Only one reactant involved in that step. That's why the rate is directly proportional to Rx means given alkyl halide. So rate is directly proportional to given substrate or given alkyl halide. Only depends on concentration of substrate. Why? Because bond cleavage step is important here. Wherever bimolecular nucleophilic substitution reaction is given, rate is directly proportional to alkyl halide and nucleophile. Alkyl halide and nucleophile here. In bimolecular nucleophilic substitution reactions, the first step is bond formation step. Bond formation step here. First step is bond formation step. Bond formation step. So here Rx is given. First step is nucleophile attacking step. Nucleophile attacking step. That means the rate is directly proportional to alkyl halide concentration and incoming nucleophile concentration. Incoming nucleophile concentration here. So rate is directly proportional to alkyl halide and nucleophile. Alkyl halide and nucleophile here. What type of solvents are favorable for unimolecular reactions? Polar protic solvents are favorable, which can donate proton. The type of solvent is favorable for unimolecular nucleophilic substitution reactions. So protic solvents are favorable: H2O, ROH, RNH2, NH3, like this. ROH means H2O means H plus and OH minus. Protic solvents are favorable for unimolecular reactions. Aprotic solvents are favorable for bimolecular nucleophilic substitution reactions. Dimethyl sulfoxide is given. Dimethyl. How many methyl groups? Dimethyl sulfur oxygen. Dimethyl sulfoxide. DMSO solvent. Dimethyl formamide. NN. The nitrogen is having how many methyl groups? 2 methyl groups. NN. The nitrogen is having 2 methyl groups. NN dimethyl formamide. NN dimethyl formamide here. Dimethyl formamide. Acetone, methyl cyanide compound, nitro compounds which is not carrying OH group or H plus donor. So this type of solvents are favorable for bimolecular nucleophilic substitution reactions. So this type of reaction is generally called what? Unimolecular reactions. Molecularity is equal to 1, rate order is equal to 1. Bimolecular reactions, molecularity is equal to, according to kinetic theory, order is 2 here. That means second reactions and first order reactions. These are the differences in between unimolecular nucleophilic substitution reactions and bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions. Next one is factors affecting on nucleophilic substitution reactions. Factors affecting on nucleophilic substitution reactions here. First one is nature of substrate. First one is nature of substrate. Nature of substrate or nature of reactant. So given reactant, nature of given reactant. Nature of leaving group. Leaving group. Nature of nucleophile. Nature of nucleophile. Nucleophilicity. Nature of nucleophile means outgoing group. Incoming nucleophile. Nature of leaving group means outgoing nucleophile. Nature of solvent. Nature of solvent here. These are the 4 factors. So nature of substrate or reactant, nature of leaving group, nature of nucleophile, nature of solvent here. nature of solvent. So we will discuss about first factor, which one, nature of substrate or nature of given reactant or nature of given alkyl halide here. Alkyl halide. First one is nature of substrate. First one is nature of substrate. First one is nature of substrate. Nature of substrate means tertiary alkyl halides undergoes unimolecular nucleophilic substitution reactions. Why? Because the reaction proceeds via more stable intermediate. More stable intermediate, more stable carbocation intermediate here. So what type of alkyl halides undergoes unimolecular nucleophilic substitution reactions? Tertiary alkyl halides. So here trimethyl carbocation is given. Trimethyl carbocation. Here ethyl, methyl, dimethyl, methyl, ethyl carbocation is given. Here phenyl carbocation is given. Phenyl dimethyl carbocation. So this is the way to explain the substrate reactivity. So this one is more stable. This one is more stable means the compound reactivity is more. So tertiary alkyl halides undergoes unimolecular nucleophilic substitution reactions. Unimolecular nucleophilic substitution reactions. Now the reactivity order is here tertiary is greater than, here tertiary is greater than, here secondary is greater than, like this. Already we have discussed that reactivity in differences. So tertiary alkyl halides are more favorable for SN1 reactions. SN1 reactions. Wherever SN2 is given, bimolecular nucleophilic substitution reactions is given, primary alkyl halides are favorable for bimolecular nucleophilic substitution reactions, because already I told you steric effect is more means the compound reactivity is less. Why? Because attacking of nucleophile to reactant somewhat difficult. Number of alkyl groups or number of other groups increases, the compound bulky nature increases, then steric nature increases, reactivity decreases. So normal compounds are highly favorable for bimolecular nucleophilic substitution reactions. Normal compounds means CH3X. CH3X type compounds are very favorable for bimolecular nucleophilic substitution reactions. So for example here CH3X is given, CH3X is given, here CCX, nothing but CH3, CH2X is given, like this. So this one is favorable for, more favorable when compared to remaining alkyl halides. Remaining alkyl halides. Steric nature is important in SN2 reactions. SN2 reactions. That means primary alkyl halides are more reactive when compared to secondary alkyl halides are more reactive when compared to tertiary in bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions. Here aryl halides and vinyl halides do not involve in nucleophilic substitution reactions. Aryl halides and vinyl halides. Vinyl means what type of functional group? Already I told you, C double bond C. The function is generally called what? Vinyl functional group. For example here Cl is given. Cl is 7th A group element. 7th A group element means how many bonding electrons? Only one bonding electrons, remaining 3 lone pairs. How many lone pairs here? 1, 2, 3 lone pairs. Given system is conjugated system, lone pair migrate towards single bond, the single bond becomes to double bond here. The single bond becomes to double bond. So here Cl plus and minus. Cl plus and minus. According to that concept, somewhat difficult to break this bond. We required more amount of energy. We required more amount of energy to break carbon halogen bond. Wherever we required more amount of energy means the bond stability is more, reactivity is less. So here also same thing. Vinyl like this, aryl halide is given. Aryl halide is given. Aryl halide means again same thing. Chlorine is connected with what? Carbon, double bonded carbon. Given system is conjugated system. Resonance is possible here. Lone pair migrates towards a ring and pi bond migrates towards ortho position here. This is the way the single bond becomes to double bond here. So according to that concept, we required more amount of energy to break that double bond nature. Due to that reason, vinyl halides, aryl halides do not involve in nucleophilic substitution reactions. But aromatic halogen compounds reactivity increases in the presence of electron withdrawing group. I think already you know how to identify the given group is withdrawing group or donating group means based on the inductive effect or mesomeric effect we can explain. If aromatic ring is carrying withdrawing group, then the aromatic compound reactivity increases towards nucleophilic substitution reactions. What is the concept in this case? Withdrawing groups increases an aromatic ring, the compound reactivity increases towards nucleophilic substitution reactions here. For example, here aromatic ring is given which is having X here. Supposed to be here electron withdrawing group is there. When compared to this one, compound reactivity is more due to the presence of electron withdrawing group. Number of electron withdrawing groups increases an aromatic ring. The ring reactivity increases towards nucleophilic substitution reactions. On ring, number of withdrawing groups increases, electron withdrawing groups increases like NO2 groups, CN groups like this increases. The total compound reactivity increases towards nucleophilic substitution reactions. This is the way to explain the aromatic compound nucleophilic substitution reactions. So bridged halogen compounds reactivity is less. Due to that reason, bridged compounds will not participate in nucleophilic substitution reactions, but not all compounds. Based on the ring size, we can explain what type of compound involved in nucleophilic substitution reaction even though having bridge nature. Based on the ring size, we can explain. So some bridged compounds will not participate in nucleophilic substitution reactions. Here. Nucleophilic substitution reactions. For example, here CH3 is given, here NH is given, here CH2Cl is given. Again CH3 is given, here O is given, again CH2Cl is given. Again CH3 is given, S is given, S is given, SH is given like this, or here CH2Cl is given. You remember, by the removal of Cl we will get positive charge on carbon. You remember always, when you remove that one, we will get positive charge on carbon. Given system is conjugated system or not? Yes. Reason, the connected atoms are having lone pairs. According to mesomeric effect, intermediate stability is more here. That means when compared to normal alkyl halides, these type of compounds is given towards nucleophilic substitution reactions, more reactivity is there. 1, 2, 3. 3. Based on the mesomeric effect, we can explain that concept here. Conjugated systems are possible here. Conjugated system possible means more stable intermediate. So SN1 reaction is given 1 is greater than 2 is greater than 3 compounds. 3 compounds. So based on the stability order, we can explain reactivity in this case. Reactivity in this case. So supposed to be here SN1 reaction order, supposed to be cycloheptatrienyl carbocation is given. Cycloheptatrienyl carbocation. For example, here CS2Cl is given. CS2Cl is given. CS2Cl or PCH2Cl is given. CH3 group is given. CH3 group is given. Here tertiary carbocation is given. Tertiary carbocation is given. Here secondary carbocation is given. Here secondary carbocation is given. Here primary carbocation is given. Here normal carbocation without connectivity. So tropylium carbocation is more stable when compared to this one. Due to that reason, the reactivity order is like this. In SN1 reactions. In SN1 reaction. For example here, compound is given like this. CS2 plus is given. CS2 plus is given. Here CH plus is given. Plus is given. Plus is given. Primary carbocation, secondary carbocation and tertiary carbocation. All these compounds undergoes unimolecular reactions because these carbocation stability is more when compared to normal carbocations. Which one is more reactive towards unimolecular nucleophilic substitution reactions? Tertiary is more reactive. Tertiary is more reactive compound here. Tertiary is more reactive compound. For example, here CH3 is given. Here NH is given. NH is given. NH is given. Here CS2 plus is given. Here CS3 is given. O is given. Here CS2 plus is given. Here tertiary carbocation is given. Tertiary carbocation is given. Here secondary carbocation is given. Here primary carbocation is given. Primary carbocation is given. Which is more stable? So this one is more stable means reactivity is more. When compared to this one, reactivity is more here. When compared to this one, reactivity is more here. This is the way to write that unimolecular nucleophilic substitution reactions reactivity order. Wherever bimolecular nucleophilic substitution reaction is given, here SN2 is given. Here SN2 is given. Here CS2 plus is given. Here withdrawing group is there means more reactivity when compared to normal compounds. So here RC double bond was CS2 plus is given. Here RO CS2 plus is given. RO CS2 plus is given. Benzyl carbocation reactivity is equal to that of methyl carbocation, nothing but methyl CH3Cl. CH3Cl primary compound here. Primary compound here. Primary compound reactivity is more when compared to secondary compound, normal connectivity primary and secondary primary and tertiary primary compounds. Tertiary primary compounds. So withdrawing group is there. Withdrawing group is there means alpha and beta position. Withdrawing group is there means towards bimolecular nucleophilic substitution reaction, the compound reactivity is more. So simple compound is given, we can identify easily primary, secondary, tertiary and normal compounds. But here secondary compound, primary is given means majority of the reactions are bimolecular reactions. Tertiary is given means majority of the reactions are unimolecular nucleophilic substitution reactions. Normal secondary is given. How can you decide given compound undergoes unimolecular reaction or bimolecular reaction? Means based on the given reagent. We will discuss that concept in examples. So this is the way to write that reactivity orders of or nature of substrate, nature of reactant here.